Coryphodon is one of the first large-bodied mammals that was abundant during the Paleocene-Eocene epoch post-KPG. This makes it an ideal animal to study in regards to the effects of the Paleocene-Eocene thermal maximum, or the PETM, a major global warming event. Previous hypotheses suggest that this large animal underwent dwarfism in response to the PETM. However, here we test this hypothesis using stylopodial limb circumference to derive body mass and compare our results to body mass estimates derived from teeth, the former method used to predict body mass. We also test to see if limb circumference can be predicted using other non-femoral elements. To test this, limb bone diaphyseal least circumference and lower first molar lengths and widths were measured in 7 specimens. Various limb bone measurements were regressed on femur circumference to examine intraskeletal scaling. This correlation then allowed for the prediction of body mass in individuals with missing elements. Body mass was calculated based on limb bone measurements and the lower first molar M1 area using the following formulas by Campion, Evans, and Ewan Gingrich. In figure 2, you can see some of the elements that were measured. You can see that on figure A, you can see that the blue line represents M1 length, whereas the yellow line represents M1 width. The red lines represent least circumference in limb elements on both B and C. The results of this study demonstrate that humeral, radial, and tibia elements all correlate tightly with femoral circumference, thus allowing femoral circumference to be estimated from these limb elements. Thus, we can predict body mass without the femur if these prior mentioned limbed elements were found. Furthermore, mass estimates that utilize stylopodial circumference yield larger mass values in kilograms compared to mass estimates that were predicted from the M1 area. Table 2 here demonstrates the difference between prediction of body mass using M1 and the prediction of body mass using limb circumference. As you can see in some of the specimens like UM 98538, YPM 16131, UM 117640, you can clearly see that body mass in kilograms greatly exceeds those predicted by M1. In conclusion, stylopodial circumference yielded larger body mass estimates than estimates based on lower molar size. This suggests that estimates based on tooth area underestimates body mass in Coryphodon. Femoral circumference can also be predicted from humeral, radial, and tibial circumference, which will allow for the estimation of body mass in incomplete specimens. This data set forms the basis to further investigate body mass changes of Coryphodon during and after the PETM, and hopefully aid in determining whether or not there was, in fact, dwarfism during the Paleocene-Eocene thermal maximum.